And welcome to the Daily Space Weather. We've got some fireworks on our way, and some have already arrived. Some relativistic particles have already shown up from the most recent coronal mass ejection. So you'll see a solar flare right at the end of this clip right here. Peak flux was at 840. We'll get to it and lots more. Lots of sunspots larger than the Earth on the Earth-facing portion of the disk. New sunspot in the north as well. The flare actually came from this pretty simple sunspot over here in the southeast. The radial flux still only at 102, expected to jump up precipitously. A big increase coming in the radial flux today. Again, it's only at 102. No space weather storms forecasted. And no major CMEs headed toward the Earth. Those were just relativistic particles that came out of the flare, and we saw a large earthquake right as we started to record the show. So here southwest of the Alaskan Peninsula, that was a 6.7 magnitude quake. At the current time, no tsunami watches, warnings, or threats. I'll press refresh, and we'll get this video uploaded as quickly as possible. Pardon if the pace is a little bit faster than normal. So scrolling up the list here, again, the largest quake of the past 24 just occurred. Only a few minutes before we recorded the video, there was a 5.7 near Fiji at depth. So deep quake still striking there north of New Zealand. Also Cyprus saw a 6.6. So that Alaskan quake outdoing the Cyprus quake by a tenth of a magnitude. So two major quakes there happening in the past 24 hours. Lots of stuff going on in the sun as well. And there we already see some aftershocks coming in there. The heck? It's been downgraded to a 5.5. There you go. We've just documented a downgrade for you, folks. Largest quake of the past 24. Now this is 6.6. Anyway, we caught it. We actually uploaded it to our website. A screenshot of that at smashamash.com/smashteam. Let's see what's shaking as far as volcanoes. Karimsky's exploding. 14,000-foot ash plume from Karimsky. Shivaluch. Similar sized volcanic ash plume, flight level 140, as Shivaluch explodes. So two Kamchatkan volcanoes going off there. Subanosejima also producing an unknown size volcanic ash cloud. Luitolo now back on the list, flight level 070. Yowzers. Also Fuego exploding. That's in Guatemala. No volcanic ash seen in satellite on Nevado del Ruiz. So no apparent flight risks there. Maybe don't fly your hang glider over Nevado del Ruiz. Sangay exploding. 21,000-foot ash plume from Sangay. Revenador, they're both in Ecuador, Sangay and Revenador. Revenador continues to explode with a 15,000-foot plume of volcanic ash. Intermittent puff emissions from Sabancaya. P. Diddy sponsored that volcano, intermittent puff emissions. From there, cheers. Don't pole vault the caldera. Welcome to the Neo Renaissance. Check out our homepage, smashamash.com. You can find our merch shop there. No, that stuff's not misspelled, folks. Welcome to the Neo Renaissance. Members of the Smash team would have already seen and gotten emails if they're subscribed to the email list about that quake. You just actually saw it. It just occurred while we did the video. Anyway, no tsunamis, watches, or warnings, folks. That's good news. So lots of stuff going on with the sun, including some slight upticks in the solar flaring, although sunspots are still underperforming. There's your GOES magnetometer data. Here's the Gong 2 data. Earth remains in a South Pole current sheet. Shown there in red. There's the line of sight view from the Gong 2 data. the Gong 2 data, some of the most important data that there is. All of that integrated magnetometer data from stereo A, stereo B, and ground-based magnetometers. There's your coronal hole line of sight plot, and we've got some nice zoom-ins. Some coronal holes here. We've got this V-shaped coronal hole that people will be very frightened of on the internet today. Maybe it will stand for victory. Anyway, check it out in 193 angstroms. There was a bit of a smiley face sun going on yesterday, but that has now subsided. Here's a close-up in a different wavelength. 211 shows the great depth and lack of that iron ion in that coronal hole. And keep in mind, folks, there are protons blasting out. That is a cosmic ray source right there, folks. Protons are blasting out of there at a high rate of speed. It's what coronal holes do. And that might be providing some increased solar. It's gone transequatorial, so we may see an increased geomagnetic situation from said protons and their induced current. You can even see it in 304 angstroms. Also a great view of that C-class solar flare that sent the relativistic particles our way. Some have already showed up. And this gives you a different sort of a depth view, looking at the lower corona here in 171 angstroms. Spectacular views there of that well-defined coronal hole. Next, sunspots. We'll show you a close-up. They've mostly been stable here. And you can see the flare came out of basically it looks like an alpha-class sunspot to me. I don't see any second ombre there. Right there, you can see that little flare happening, that C-class flare. And likelihood for major flares is going up big time. Sunspot 2924 has had its leading umbra degrade. So this is going to decrease the ability for those magnetic fields to continue holding up that plasma. Coronal mass ejection warning as a result of that. Also, as this approaches the limb, I think Mr. Bagashov will agree that it is more likely to flare at the limb, slightly statistically more likely to occur around the limb than right in the center of the sun. And leave a comment if you would agree, disagree, or just for fun. So there's that C-class flare, only a C-class flare. Peak flux was at 840 there. And you see a tiny spike in the relativistic particles there, those taking only about 3 hours to arrive. A little under 3 hours for a tiny spike in the relativistic particles. Probably didn't cause very much of a disruption or anything. No need to worry about radio blackouts from that. That's barely even a signal. Now we see a drop down of the solar wind here, a continuing subsiding of the coronal hole wind stream. Speed now down to about 400 kilometers a second. Density about 7 protons per cubic centimeter. KP1, that's a measurement of global geomagnetism. And we're going to see we're actually capturing the magnetosphere in its equilibrium state achievement here. So this is sort of the plasma having a sort of a calm and steady enough stream to sort of subside from that coronal hole wind stream. It's a perfect example of the way the magnetosphere has to bounce back and forth as plasma gets shifted around up there, changing the induced currents. So just a great view of that there. You can see where the field-aligned currents are most likely to be based on a lot of measurements, which is what the space weather modeling framework is. That's 4 hours of data, by the way, courtesy University of Michigan. Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. It's showing magnetic flux density. It's sort of the end of the bell ringing of the Earth's magnetosphere. It's the tone being established at the end of the bell ring. Next, solar system diagram. There must be some great photos of Venus on the internet. Let's have a look. And indeed, here at spaceweather.com, we see one from Paolo Bardelli. The morning star is back. There you can see a great image of phased Venus. That one linked from spaceweather.com. Here's a solar system diagram. We'll advance it 1 week. Full moon is on or around the 17th, 18th, something like that. Let us know in the comments if you'd like to refute this theory. I consider it close enough, but in any case, depending on your werewolf or reverse werewolf status, you may care or not care or have a completely dark sleep chamber. Just saying. Next, a star chart. This is what's going on over Lehigh Valley. Mars has risen ahead of the sun. And Venus just on the horizon. If you've got a low horizon, you may see Venus and Mars out there. Classic imagery. Coronal mass ejection warning, folks. A bunch of plasma is going to eject. You've got a great view of it from L5, the location of stereo A. This plasma right here is what we're talking about. This plasma is on its way out. So some of this might collapse and land back onto the solar corona, but some of that will eject. Mark my words. And we brought up the LASCO C3 here because great view of Venus on there. Located at Lagrange point 1, the LASCO C3 here on the right. Check out the astronomy picture of the day. It's part of our integrated cosmology segment. You may see something familiar. I'm going to slowly move up here on this high-res image of a nebular cloud in multiple different spectral wavelengths. You may see something familiar. Is that the Horsehead Nebula? Well, indeed it is. Right down here, the Flame Nebula. Two very famous nebulae there in the Orion belt stars. So one of the more interesting portions of the Milky Way galaxy. It's in a nice close range. So when we view this in different wavelengths like this, we get great views of all kinds of gases. Different gases. This is probably, I don't know, X-ray, hydrogen, maybe carbon monoxide. Let's see if it tells us what the spectra is. Anyway, multiple nebulae there on the astronomy picture of the day. We integrated this cosmology segment into the space weather video. Anyway, whatever those spectra are, also optical wavelength probably in there. It's a dusty region. It's an exciting nebula. If you've never seen Orion's belt like that before, cheers. It's the astronomy picture of the day. Let's look at something else weird. One of the weirder objects. We're going to calculate a random number here between 1 and 76 for 16. One of the black hole candidates here at the Swift-Bat X-ray Observatory. It's MAXI-J 1543-564. We're going to bring up the full light curve here. There is the X-ray, the hard X-ray emissions over the last 30 days from this one. And let's go look at it on the CDS portal. That brings us into the optical bands here on the DSS colored. Let's full screen it and see what it looks like in visible light. And it looks like not much. It's visibly dark. But in infrared, which is what the James Webb Telescope is going to be looking at, we do see a signal there. So an interesting shaped heat emission from that area. One of the weirder objects you'll find on the Neil Gehrels, MAXI-J 1543-564. And you can find a ton of information there on the CDS portal if you want to read more about that. And it is indeed an X-ray binary, believed to be an X-ray binary. So that's the best signal we'll get. We'll zoom way out. And that's a lot of data there, folks. I apologize for the the screen redrawing. Anyway, there's a great infrared signal there. Kind of a cold spot between a few symmetrical looking hotspots. That's MaxEJ 1543-564. The X-ray binary. And that's number 16 on the potential quote black hole and quote massive radio sources that you can link to at the main transients page there at the Neil Gehrels. That's today's cosmology segment. Let's move on. Charging hazards, we don't see any. Electron flux over the past year, it's now very low, nearly as low as it gets. Here it is over the past 3 days. It will come back up in the next day or two. By 36 hours, we'll see more normal curves, most likely. NOAA agrees. There's the forecast. The green boxes are the forecast. The yellow diamonds are Lucky Charms marshmallows. Next, GPS errors via the total electron content forecast. One of my personal favorites. And you can actually go test this out with your GPS, folks. If this shows a red blob above where you are, go out using only your GPS and not your location accuracy Wi-Fi services. You will find that it is off by a lot. Next, the ionosphere. Here's one slice of it, the F layer. There's a lot of vibration going on up there, and there it is. The past day, 2 hours per second is the time frame there. Here's the anomalygram. And we see continued anomalies around the Drake Passage. Let me just comment on the Drake Passage once again. This area right here is one of the weirdest places on the entire planet, as the Atlantic Ocean has to attempt to reach thermal and pressure equilibrium with the Pacific Ocean. That means that there's got to be a lot of water sloshing back and forth. Imagine what it's like if there's a low pressure over here and a high pressure over here. Lots of water sloshes back and forth through the Drake Passage. It's a weird, weird place. And one of the most dangerous seas in the world. Anyway, here's the latest image. That's 12 o'clock Universal Time ionogram. There's the anomalygram. Things actually looking pretty normal there at that moment. Bonus features. So we've got some clouds over Cerro Tololo. That's our first bonus feature, the ground-based solar observatory there. It's not Trololo, you know. Yeah, 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 yeah. You know that song? The Soviet lyricless, the song that had the lyrics removed because of communism. Yeah. It's for real. I'm not kidding, folks. If you look up the Trololo song, lyrics were removed because communism. I'm not kidding. Anyway, there's the ground-based solar observatory at Cerro Tololo, Chile. Expect flares and expect CMEs. They're coming. Next, the GOES 16 SUVI, and you can see a massive prominence here in the northeast. Some of that has ejected. That is not likely to be earthly in nature. That's headed someplace else off in the solar system, most likely. Next, latest intensitygram and colorized magnetogram. We let it refresh on your screen so that you can see that it is the latest. Check it out. We see a little bit of degradation there of the leading umbra. I believe that's going to make flaring more likely, but certainly moving toward the limb makes flaring a little bit more statistically likely, in my opinion. I've looked at some data on this, and it's fairly compelling. I would say 20% more likely, something like that, all things considered. And of course, we've got another sunspot up here in the northwest. It's barely a beta-class sunspot. It's not particularly magnetically complex. that area has produced some relativistic particles. We could have a little bit of a tiny blip in the solar high-frequency bands. In any case, there's the there's the 2924, one of the largest sunspots of the cycle. We'll close things out at 304 angstroms ionized helium. It's fantastic imagery from the SDO. And you can see a coronal hole here northeast of both of these sunspot groups. I find that interesting. What say you? Let us know in the comments. And don't forget to visit our other links to support the channel if you'd like to see these videos continue to exist. In any case, thanks for tuning in. May that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of the smAsho News Network, least busted name in news.